Welcome to this lesson on core electrons, a fundamental concept in understanding atomic structure. Core electrons are the inner shell electrons that play a crucial role in how atoms behave, though they don't directly participate in chemical bonding. Core electrons are defined as the electrons occupying the filled inner shells of an atom. These electrons are located closer to the nucleus and are not involved in forming chemical bonds with other atoms. They remain stable within their shells and don't participate in chemical reactions. Let's visualize the difference between core and valence electrons using sodium as an example. The blue inner shells represent the core electrons, which are tightly held near the nucleus. The green outermost shell contains the valence electrons, which are responsible for chemical bonding. Understanding this distinction is essential for predicting how elements will behave chemically. Sodium has an electron configuration of 1s2, 2s2, 2p6, 3s1. The core electrons are found in the first and second shells, 1s2, 2s2, and 2p6, giving us a total of 10 core electrons. The valence electron is the single electron in the outermost shell, 3s1. This single valence electron makes sodium highly reactive. Core electrons have four key properties. First, they are shielded, meaning they're located very close to the nucleus and are tightly bound. Second, they occupy lower energy levels, making them more stable than outer electrons. Third, they are non-reactive and do not participate in chemical bonding. Finally, they create a screening effect, shielding the outer valence electrons from the full attractive force of the nucleus. There's a simple formula to count core electrons. The number of core electrons equals Z minus the number of valence electrons, where Z is the atomic number, which represents the total number of electrons in a neutral atom. By subtracting the valence electrons from the atomic number, you can quickly determine how many core electrons an atom has. Let's look at three more examples. Carbon with configuration 1s2, 2s2, 2p2 has 4 valence electrons and 2 core electrons. Chlorine with configuration 1s2, 2s2, 2p6, 3s2, 3p5 has 7 valence electrons and 10 core electrons. Calcium with configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 has 2 valence electrons and 18 core electrons. Notice how the number of core electrons increases as we move to heavier elements. Let's review the key takeaways. Core electrons occupy filled inner shells and remain close to the nucleus. They do not participate in chemical reactions or bonding processes. They shield valence electrons from the full nuclear charge, reducing the effective nuclear charge felt by outer electrons. To count core electrons, simply subtract the number of valence electrons from the atomic number. Understanding core electrons is essential for predicting chemical behavior and atomic properties.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.